Good morning, children. In this unit, Atomic Structure, what we have learned so far? A small recap. Already we have learnt about the Dalton's atomic theory and the advantages of Dalton's atomic theory and its limitations, isotopes and isobars. Then with the CRT, Sir William Crookes CRT tube. Discovery of fundamental particles, electrons, neutrons, and protons by the scientists using this CRT tube. Since we have some limitations over Dalton's atomic theory, we could not define the structure of an atom. So, today's session we will start the discussion with J.J. Thomson's atom model. J.J. Thomson, an English scientist, proposed the famous atom model in the year 1904, just after the discovery of electrons. Thomson proposed that shape of an atom resembles like a sphere. It has the radius of 10 to the power of minus 10 meters. He proposed that the positively charged particles are uniformly distributed, with the electrons arranged in a way that atom is electrically neutral. But Thomson could not define what the positively charged part of an atom really contained. He also did not clearly explain whether the electrons in the positively charged sphere are fixed or move about randomly. Thomson's atom model was also called as plum pudding model or the watermelon model. The embedded electrons resemble the seeds of watermelon, while the watermelon's red moss represented the positive charge distribution. This plum pudding atomic theory assumed that the mass of an atom is uniformly distributed all over the atom. Still, we have some limitations of Thomson's atom model. Thomson's atom model could successfully explain the electrical neutrality of atom, but it failed to explain the following. Thomson's model failed to explain how the positively charged sphere is shielded from the negatively charged electrons without getting neutralized. Second one, this theory explains only about the protons and electrons and failed to explain the presence of neutral particles, neutrons. Now we start our next heading, valency. In order to understand valency of elements clearly, we need to learn a little about Rutherford's atom model here. According to Rutherford, an atom consists of subatomic particles, namely protons, electrons, and neutrons. Protons and neutrons are found at the center of an atom called nucleus. Electrons are revolving around the nucleus in a circular path called orbits or shells. This is the nucleus of an atom which contains protons and neutrons. So, the atom has the center part nucleus and orbits which contains the electrons. The number of electrons arranged in each shell with the standard configuration. This arrangement of electrons in the orbits around the nucleus is known as electronic configuration. So what is electronic configuration? The arrangement of electrons in the orbits around the nucleus is known as electronic configuration. You know that atoms of all elements will have a stable configuration. They will tend to have either two electrons. If the orbits have, that is the outermost orbit, they tend to have two electrons, that means duplets. What are that? Known as duplets. If the outermost orbit tend to have 8 electrons, then it is known as octet. So duplets means arrangement of 2 electrons. Octet means arrangement of 8 electrons to have their electronic configuration. For example, helium. Helium is what kind of element helium? It's a non-reactive element, inert gas. Why? It has 2 electrons in its outermost orbit, so that it is chemically inert. The same way, neon. Neon also chemically inert because it has 8 electrons in its outermost orbits. The valent electrons in an atom readily participate in the chemical reaction. So the chemical properties of the elements are determined by these electrons. The number of electrons that present in the outermost orbit helps the elements to combine with another atom to make a chemical reaction. So this combining capacity of an atom is called valency. So this combining capacity of an atom is called valency. In other way, we can say valency is defined as the number of electrons lost or gained, or two atoms can share the electrons. Share. So number of electrons lost, gained or shared by an atom in a chemical reaction is known as valency. So it makes the atoms to be chemically inert. So the number of electrons lost, gained or shared by an atom in a chemical combination to make the atom inert is known as valency. Now we will see the types of valency. So in order to understand this valency in a better way, that it can be explained in two ways depending upon the atoms, number of atoms gain or loss. First we will see the metals. Atoms of all metals will have 1, 2, 3 electrons in their outermost orbit. Say, so metals have 1 to 3 electrons in their outermost orbit. So they need to lose these electrons while in a chemical reaction to have a standard configuration. So the metals which lose electrons will have positively charged because their positive charges will get increased and the number of electron it get lost, isn't it? So for example, sodium. Sodium has the atomic number 11. How these electrons are arranged? This is the nucleus. These are the orbits. This is the first shell K. The number of atoms that occupies this K shell is 2. This is L. The standard number of electrons here it occupies 8. And this is the shell M. Already 10 electrons have arranged. So what is remaining? Only 1. This electron is revolving in the outermost orbit of a sodium atom. So what is the valency of sodium atom? While it combines, it loses this electron and the number of protons remains the same. So sodium has the valency of positive. It has positive valency. We'll see one example for negative valency. Understand metals gains positive valency. Non-metals. Non-metal tends to have 4 to 8 electrons in its outermost orbits. So, the non-metals gains the electron from the other atom while participating in a chemical reaction. We can take the example chlorine. It has 17 number of electrons. How it get arranged? Here K shell 2 electron, L shell 8 electrons, remaining 7 electron get arranged in this outermost orbit. So this need one more electrons to be get a stable configuration. So while chlorine when reacts with other atom, it gains one electron. So automatically the number of negative charge increase in this. So chlorine gets the negative valency. Here we saw sodium. Sodium positively charged, so it is a positive valency. Chlorine here gains the electron, so it gets the negative valency. With respect to atoms, some atoms are taken as a standard one to determine the valency of an atom. Such atoms are hydrogen, oxygen and chlorine. What are they? Hydrogen, oxygen and chlorine. First, we'll take hydrogen. Valency with respect to hydrogen. Valency with respect to hydrogen. What it is? How can we decide the valency of an atom with respect to hydrogen? Hydrogen atom lose one electron because it has only one electron in its outermost orbit. So, its valency is taken as 1 and it is a standard atom. So, valencies of other elements are expressed in terms of hydrogen. How? The valency of an element can also be defined as the number of hydrogen atom which combine with one atom of it. What it is? Number of hydrogen atom the number of hydrogen atoms which combine one atom of 8. We can explain with this with an example. One hydrogen atom combined with one chlorine atom. Thus, the valency of chlorine is 1. Only one hydrogen atom can combine with one chlorine atom. So, what is the valency of chlorine? The valency of chlorine is 1. Same way, another compound, water. What is the molecule of water? H2O. So, how many hydrogen atoms here combined with oxygen? Yes, 2. Oxygen can combine with 2 hydrogen atoms. So, what is the valency of oxygen? The valency of oxygen here is 2. Okay. Do you understand how to find the valency? Okay. Now you can say the valency of the atoms which I am underlining. Can you? Yes. What is the valency of chlorine here? One hydrogen atom attached here. So, valency here is 1. Here valency of oxygen 2. What is the valency of nitrogen here? Yes, 3 hydrogen atoms are attached here. So, the valency of nitrogen is 3. Here the valency of carbon is how much? Yes, it is 4. Some of the elements do not combine with hydrogen. The valency of those elements is also defined in terms of other elements like oxygen and chlorine. And this is because almost all elements combine with chlorine and oxygen. So, we can consider the valency of all metals or all other elements with respect to any one of these elements. Next, valency with respect to chlorine. You already know chlorine possesses negative valency of 1. So, the atom which combined with chlorine will get its valency. Shall we see some example? First one, sodium chloride. NaCl. One atom of chlorine get combined with sodium. So, valency of sodium is 1. Another one example, magnesium chloride. What is magnesium chloride? MgCl2. Here 2 chlorine atoms are attached with magnesium. So, the valency of magnesium is 2. Okay, here 1. So, the elements which do not react with hydrogen surely combine with chlorine and get its valency. The valency with respect to oxygen we will see in our next class. Today's session we have seen Thomson atomic model, some of its limitations. Then valency, combining capacity of an atom. Types of valency, positive and negative valencies. Valency with respect to hydrogen and chlorine atoms. Attend a small quiz with respect to today's class. We will meet again. Thank you.